Robotics Pathway 2026 Rollout webinar for teachers. My name is Brent Curran, and I am the education consultant for computer science, IT, and technology education here at the Department of Public Instruction. So let's go over some course information, and you can view that information today using our course management system. All right, so in the new school year, we are moving to the new advanced CTE framework. So that framework has a bunch of different cluster groupings. Ours is going to be connecting and supporting success. And then within that, you'll see the cluster digital technology and computer science. And then that's where we'll start to see our typical pathways. All right, so of course, the pathway is robotics, and our prerequisite is going to be CA21 Robotics I, followed by our concentrator course, CA22 Robotics Level 2. Here's the course descriptions. You typically read this as a whole paragraph, but I broke it out so you can kind of see the difference between the two courses side by side. So in Robotics I, they're going to design robotic systems, whereas in Robotics II, they're going to construct advanced robotic mechanisms, such as an arm or some sort of drivetrain. Level 1, they're going to perform basic autonomous tasks, whereas in Level 2, they're going to do an autonomous routine using more advanced sensors and control systems. Level 1, we're going to troubleshoot, we're going to do hands-on experimentation, whereas in Level 2, they're going to start integrating some things, and they're going to do some tuning techniques to improve their performance. And of course, for both courses, they're going to gain knowledge, skills for the careers in the robotics pathway. All right, general information for both courses. Your course lead consultant will be Mike Renee. That's effective July the 1st. The course status of the course pilot. These were LCO courses, originally geared for the VEX robotics system. We've now taken them to state management, and we've open-ended it. So instead of being forced to use VEX robotics, you can use the robotics system that your public school unit decides to go with. So the proof of learning is going to continue to be local. The hours of instruction, 135 to 150. So that depends on if you're in the block schedule or the traditional schedule. We recommend a maximum enrollment of 20. Robotics is kind of expensive from a cost standpoint and a space standpoint. You gotta have room to test the robots out and whatnot, so you can probably only fit about 20 students in there. And it does meet the computer science graduation requirement. With CA21 Robotics I having that star, the course can be offered in both middle school and high school. It meets that requirement. It's a high school level course. CA22 Robotics Level 2 can only be taught in high school. Again, it meets that requirement. Course outcomes. These should be shared with students so they understand throughout the course. These are the 3 or 4 most essential things that they're going to learn. This is something you can share with guidance counselors, family members, different things like that. So in Robotics I, when they finish the course, they're going to build a working robot using motors, gears, and simple electrical parts. They're going to write basic code to make a robot move and complete simple tasks. And third, they're going to use basic sensors so that the robot can detect and respond to its surroundings. Then at CA22 Robotics II, They're going to design and build advanced robotics with parts such as arms, lifts, or a drivetrain. 2, they're going to combine sensors and electronics to help a robot make decisions. 3, they're going to program a robot to work on its own without using a remote. And 4, they're going to make a robot move accurately by using control systems. Here's the course standards. I'm not going to read all of these to you, but the first two are our CLES standards, which are in all level 1 CTE courses, and then standards 3, 4, and 5, all the way down to 7. This is the real meat of the course. I recommend that 1 and 2, this is what you teach in the first week or 2 weeks of the course as you have students moving in and out, you have assemblies going on and whatnot. That's where you should teach that content. Whereas the other content, it's more stable, and you have time to go in deep with that. Here's our level 2 standards. Again, I'm not going to read these out, but 1 and 2 are our CLES standards, which are in all level 2 courses of CTE, and then 3 through 7, those are the real meat and potatoes of this course. All right, curriculum guides. These documents will be published on the Computer Science, IT, and Technology Education Moodle in the upcoming days. Really, it should be almost any hour now. We've just got the covers back from graphics, and I think that was the last piece that leadership was waiting on before they give me that final check mark to go ahead and post it. So, could be tomorrow, Monday, not really sure, but it should be any moment now. I'll get that email that it's good to post. Okay, so in our curriculum guides, we have CTSO alignment. We have some platform guidance about robots. We have essential questions for every major piece of unpacked content. We have unpacked content for each standard. We have teacher briefs for each standard. And we will also have instructional resources for each standard. So first, CTSOs, since that first course could go either way, middle grades or high school, we do have our middle grade CTSO alignment. And keep in mind, CTSOs are intra-curricular. They're not co-curricular or after school, though that is sometimes how they are run. Whether you do TSA, FBLA, or Skills USA, you can directly take these competitions as a direct replacement of course content. So it doesn't matter which one your school chooses to use, you can take those events and use it in your classroom to help you with this course. You may have to modify the rubrics or whatnot. And then here's our high school CTSO alignment. Again, for TSA, FBLA, and Skills USA. All right, platform guidance. So this is a local level public school unit decision. So I suspect everyone that's taught this in the past as the local course option, that course was written for VEX Robotics. So I kind of suspect that's what everyone's going to use. But the course now has been open-ended. You can use other systems. If you do choose to offer this as a new course, and you need a system to go pick from, we've given you some guidance on that. So as long as the system can build mechanical systems using motors, gears, and structural components, connect and safely use electrical components, wire and test basic code for movement and task completion, and integrate simple sensors for environmental detection, that platform can work for this course. For CA22 Robotics II, that guidance looks a little different. They need to design and build advanced robotic mechanisms, such as an arm, a lift, or complex drivetrains. They can integrate and interpret data from multiple sensors. They're going to develop autonomous programs using structured logic. They're going to apply control methods to improve precision and movement efficiency. All right. So the first vendor that we have partnered with is First Robotics. We've sent this to Marie at First NC, and she's very excited. For the classroom use, I kind of assume everyone's going to use the First Tech Challenge for that. I know some schools do the other higher up programs, but as you guys know, when you get into those higher up programs, it is astronomically expensive. A lot of those robots have like sponsors and whatnot to get those costs. The Tech Challenge has a lower price entry point, and I see a lot of schools do that in their classroom or want to do that in their classroom. So that's kind of our recommendation with that. Parallax Robotics, they have this Activity Bot 360. Yes, it has some gears, it has some sensors. This is something you want to pair with another product. This would be great in the middle grades classroom to kind of get everybody started and then move them slowly into something else. Let's go education. They have a series of systems on their website. They have the complete package. You're getting the parts, the notebooks, the resources, the controllers, the batteries, storage kits, everything. Rev Robotics is another partner that I would reach out to. They actually have their curriculum for free right now. I'm going to find that link and post it into the chat. But they also sell kits. They have the EDU kit V2, which is a great kit for classroom use. And they also sell some other kits geared for that First Tech Challenge and First Robotics in general. So if you're using First Robotics, Rev Robotics might be a good system for you guys to use as well. And of course, the one system everyone is already used to is Vex Robotics. We see a lot of Vex IQ, Vex EXP, and Vex V5 in the classroom. For this, I'm not really recommending Vex IQ because those are typically plastic parts. The Vex EXP and the Vex V5, that's when you get into the metal components. The Vex EXP is a kind of a cheaper system designed for the classroom, whereas the V5, that's made more for the competitive side. So a note on those competitions. If you have a team or you know of a school around you that does those team competitions, every year those components change out with a new competition. You can save all of those old components and use those in your classroom. There's nothing wrong with them. You know, you can use the outdated games from the past few years. Those are perfect materials to use in your classroom to give your students some sort of challenge to perform. And then basically any other system like the ones we've seen today, you know, I've seen Rogue Robotics. where they use some of these systems, and then they may use like a 3D printer or some wood or something else to make different parts and pieces for something. Or there could be other systems out there that I'm not aware of. If you know of any, let us know. We'll try to reach out to them and have them map their stuff to these courses. All right, so essential questions. So an essential question is for each piece of major unpacked content. We'll talk about the unpacked content in a moment. But here's an example of an essential question you would see in one of the courses. How does documentation support planning, collaboration, and iteration in the robotics? So as a teacher, how do you use that effectively? Start with the question. When you get into, I believe this is Unit 3. When you get to Unit 3, start with the question. Make it visible. Post it. Reference it. Have the students restate it as you go through that content. Break it into kid-friendly chunks. So unpack terms like mechanism, simple machine, and function so that students know what they're doing. Revisit it during the learning, not just what is at the end. So as you're doing activities, pause and ask, what part of the question are we answering right now? Tie every activity back to the question. So after you do a lab or a build session, have students explicitly connect what they did to how mechanisms work. Use it to drive discussion, not just the answers. So encourage students to compare ideas, debate which mechanisms are most effective, and have them explain why. Require explanation, not identification. Push students beyond this is a gear to this gear changes speed and torque because X, Y, and Z. End it with reflection tied to the question. Have students write, sketch, or explain how their understanding has evolved. Use it as an assessment tool. Frame it as an exit ticket, a quick response, or a project reflection around the question. So this is how are you going to use this piece from the curriculum guide in your lesson. Unpack content. So this piece of unpack content, we're at K. Every letter is a major piece. So I have A through K in this. This would be Unit 3. So there's a whole bunch of unpack content, pages and pages. This is what I would consider a unit or a lesson. It may take you a day, may take you a few days. Kind of depends on which piece of content we're talking about. So this one is understand how documentation supports planning and improvement. Under that, you've got your major ideas, engineering notebook routines. And then if I didn't know what was in an engineering notebook, it tells me, okay, I should probably have something about dates, versions, decisions, and results. Okay, and then build documentation. So I gotta have my students create some sort of build documentation. So I'm going to have them do some sketches, maybe come up with a parts list, and maybe some notes on how they're going to wire their robot. We're going to need troubleshooting documentation. So if something goes wrong, what's the symptom that they're having? What's the hypothesis that they think the issue is causing? What's the change that they're going to do? And what was the result of that change? And then we're going to teach our students that team documentation supports collaboration and continuity. All right, so delivering unpacked content. Teach it function, not just the names. So every mechanism, what does it do? How does it change motion or force? Connect simple machines to real robot systems. So if we're going to talk about link levers, arms and pulleys, lifts and gears, or drivetrains, what do they do? What are the advantages, the disadvantages? Use hands-on exploration early. Let students see and feel how mechanisms change the movement. Ask why and how constantly. For example, why use a gear instead of a direct drive? How does this reduce friction? Chunk the content for the students. You can group those into the groupings you see within the unpacked content. Have students explain with evidence. Require verbal, written, or diagram-based explanations of mechanisms in action. Use the builds as your assessment. Students apply the right mechanism for a task, not just identify it. Reinforce connections across lessons. Continually tie new mechanisms back to previous ones and the essential questions so you can create the experience of learning. Teacher briefs. So we have a teacher brief for each standard. These are big teacher briefs. They're usually a page to 2 pages. So I've got some examples here. This is for Standard 3.0. This establishes the safety mindset and the planning mindset students will rely on throughout the course. Students should understand that safety is a routine practice connected to every stage of robotics work, including building, wiring, programming, testing, troubleshooting, and cleanup. The teacher should explicitly teach and reinforce expectations for safe behaviors, safe testing practices, and safe handling of tools and equipment. And here's another example from that same standard. The engineering design process is part of the standard because planning and documentation reduce preventable errors. Students should understand how criteria and constraints guide decisions, and how prototyping supports learning, and how testing results support improvement. Documentation routines such as engineering notebooks, build notes, checklists, troubleshooting logs help students communicate decisions and support safer and more efficient iteration. So implementing a teacher brief. These are basically your best practices. Um, if you've never taught a certain component in the content, this is going to kind of give you some things to look out for and some things to call out to your students. And then we have our instructional resources. So these are for you as the teacher to explore and build your lesson plans from, so you're not starting from scratch. Yes, Vex Robotics, Rev Robotics, all of those partners, they have curriculum materials and whatnot. But for every component of unpacked content, these guides are, I believe level 1 is about 55, 56 pages, and level 2 goes to 60 pages. Most of that is unpacked content for you guys to teach with. And then we give you instructional resources for each one. So this is where you're going to go find your videos, some lessons, and some websites that may help you out. Even if you don't teach a certain system, and we have it in the guide. So I've got some things in there from First Robotics, and some things in there from Rev, some things in there from Vex. They have great examples of like engineering design notebooks that you can kind of use, steal it, and adapt it for use in your classroom. So look through those instructional resources. They're there for your support. Of course, this course is launching in pilot status. So it's going to be pilot this first year. If you want us to make any changes throughout pilot year, I want you to go to those check-in meetings and the surveys. All right, so throughout the pilot year, we have reached out to First North Carolina, Pittsco Education, Rev Robotics, and Vex Robotics. And at least Marie from First North Carolina has already agreed to do that, but she wanted to wait until after the robot season, which right now is the peak of it, so she can start working on that. Once I have one of those partners complete a crosswalk, so they're going to map their standards, they're going to map their resources to our core standards, so it should be really easy for you to look at and navigate. If I'm teaching this standard, what resources would I use? Once they complete those, we'll post them on our new CT hub for the robotics PLC. Pathway Teacher Lead. Applications for that have already launched. This is a paid stipend position. Those applications are due April the 30th. I looked the other day, and I think I only had one teacher for robotics put in an application. Teachers will need the support of your building principal and CT director. And the new Pathway Teacher Lead will be announced during Summer Conference 2026. So if you've done robotics as the LCO, or if you're teaching it next year and you've done robotics as like a first robotics coach, a VEX robotics coach, or you just enjoy robotics, please apply for this Pathway Teacher Lead. I'm thinking a lot of people are probably waiting until April 30th deadline to put in their application. But I checked last week, we had only had one so far. So if you're interested, put your hat out there. And then of course, with all of our courses, we do pilot check-in meetings and surveys. But we're right in the middle of releasing curriculum, and then we're working on a summer conference. So I haven't sat down, I guess really Mike, we haven't had the time to sit down and come up with those dates that we're going to do those meetings throughout the upcoming school year. So when we have that, we'll post it closer to the upcoming school year. And then this semester, we've had office hours. Office hours are just about every Tuesday. They're at 4 o'clock. Teachers, CT directors, administrators, principals, anyone can join those office hours to ask questions. We answer questions about our courses. We answer questions about the graduation requirement. We answer questions about our K through 12 computer science integration standards. And then, of course, you guys can always email me. You can email me, Mike, for any question and answer. You can email us at csitt@tpi.nc.gov. If you don't know who to email, this goes to our team. So it'll go to me, Mike, Michelle, and Natalie.